Monitoring geomagnetic storms is important. The result of a coronal mass ejection hitting the Earth's magnetic field, magnetosphere, and shifting magnetic field around, that has all these effects I mentioned that give rise to the geomagnetic storm. The aurora is kind of pretty, but the other effects can be devastating. So we want to keep track of that. So different governments around the country monitor the sun. This particular facility is the Space Weather Prediction Center, and it is the U.S. government's solar monitor. It works 24 hours a day, 7 days a week, 365 days a year, except during leap year it works 366 days. And so they constantly are monitoring the sun. They've got real-time images of the sun, data as to what the sun's doing, data as to what the magnetic field of the Earth is doing, data about all these kind of other things that are happening, proton counters that measure the solar wind and the solar wind speed and direction, magnetometers that measure all kind of things here as well. So all this is being monitored continually, and what they do is they issue geomagnetic storm watches and geomagnetic storm warnings, just kind of like the National Weather Service does. And so they monitor all this all the time. They're always monitoring this. They've got real-time satellite coverage, ground-based coverage, everything you can imagine to monitor the sun. A major geomagnetic storm is a big deal. So we want to avoid having some kind of issue, that we don't know about coming at us. Now, interesting thing, I always ask students, what parent agency of the United States government is the Space Weather Prediction Center part of? Everybody thinks NASA because they do the space exploration, right? Well, no, it's actually not NASA. If you look at the background, there's the logo of the parent organization right there. That is NOAA, N-O-A-A, not NASA, N-A-S-A. Okay, NOAA. Who is NOAA? National Oceanographic and Atmospheric Administration. They're the ones that study hurricanes. The NOAA is the parent organization for the National Hurricane Center. It's the parent organization for the National Weather Service, and it's the parent organization for the Space Weather Prediction Center. So all these are closely related sort of things. I think I told y'all in an earlier lecture that during a major geomagnetic storm event, there was major radiation event happening, and if you happened to be in a transatlantic aircraft at the time, you would have received over 100 chest x-rays worth of radiation. And so they held flights that were on the ground. Flights that were actually in the air, they flew them at lower altitudes where they got less radiation, but lower altitudes also meant that they used more fuel, and some of them actually had to divert and refuel rather than making a nonstop flight across the Atlantic that passengers had paid for. So they did not tell the passengers, though, that they were not going to fly because they would have gotten radiation exposure. They just said it's a weather delay. And in fact, technically that is correct because it was space weather. They rank geomagnetic storms by how much the Earth's magnetic field is deflected and fluctuates. You measure the Earth's magnetic field in nanotesla variations right here, so NT for nanotesla, and the more it varies, then the higher the rating here. So this is what we call the planetary K index, or KP. Okay, the planetary KP index measures the horizontal fluctuations of the Earth's magnetic field, and this particular measurement here is using the Boulder magnetometer. And so the more it varies, then they say the more active the magnetic field is. So this would be, getting more and more active. So this would be, like calm, and then breezy, and then so forth. By the time they get to a 4 level right here, then they start issuing alert notices saying, hey, this is getting pretty active out there. And then once it gets into the 5s and above, that is considered geomagnetic storms. And they rank the storms, 1, 2, 3, 4, 5 by how active the magnetic field is. the more active the magnetic field is, the more depressed it is, and the farther south the auroral oval is. So a KP of 9 puts the auroral oval right across the middle of the United States. So it has to get really powerful to get all the way down just another step here to where Texas is down here. And I have seen that. I have seen the aurora from Texas. There have been reports of the aurora visible from Brownsville, Texas, though the time that happened, it was actually cloudy here in North Texas, so I did not actually get to see the aurora when that happened. There have been times that the aurora has been visible in Mexico as well. NOAA and the Space Weather Prediction Center produce these KP graphics explaining what's happening with the sun at any particular time. And so this was a graphic on the left here that was in May of 2010. Green means slight activity, not much is going on. Yellow, that's a KP of 4. That's kind of an alert thing. And then when it gets to be bad here, that's where they mark it as red. That's going to be a geomagnetic storm. Okay. By the time you got to 2013, then a number of years later, the sun was less active, and so you didn't see much. 2014, very low activity because by that point we were into solar minimum. Okay. 2015, we were pushing towards more activity, big geomagnetic storm right there. Big one that lasted actually for this is early March 17 into March 18. It lasted more than 24 hours. And then this is what it looked like just a couple of days ago on October 12th, and you notice there's like barely anything at all. There was a teeny tiny bit of fluctuation for a little bit there, and then absolutely none starting in the 14th. Now, I should also point out about these days and times. This is UTC, that's Universal Time Coordinated. So you coordinated universal time, so that means it is not the time and day according to your clock. Add 5 hours to what your clock reads, and that's going to be what it's that's going to tell you the day and time, universal time if we're on daylight time, add 6 hours if we are on standard time. So that means that these times and days are a little bit ahead of what the clock reads in Texas. And again, you can get this is 2019, also near solar minimum, but we get a little minor geomagnetic storm right there. You can get minor geomagnetic storms even at solar minimum. They're typically not as bad or as long lasting as the ones you get at solar maximum. You can rate geomagnetic storms, and NOAA does this. They actually have geomagnetic storm ratings, and so that's what we'll talk about next. Geomagnetic storms, just like hurricanes with the Saffir-Simpson scale or the tornadoes, you have hurricanes, category 1, 2, 3, 4, 5. You got tornadoes that are like F1, F2, F3, F4, F5, etc. Same basic concept here. Geomagnetic storms are ranked with a similar way of doing it, G1, G2, G3, G4, G5. And you notice that a G1 or 2 storm is not so bad. You get up to a G5 storm, you're talking about major power outages, you fluctuating the Earth's magnetic field so much that you can actually get electrical current running down pipelines. It actually degrades the properties of pipelines. When they put a lot of metal pipelines into the ground many years ago, they never assumed electrical current be flowing up and down them. But it does because of geomagnetic storms. Pipelines are failing all over the country prematurely because they've been degraded by electrical currents that no one knew was actually going to be going through them until after we started studying geomagnetic activity. The other thing is it's knocked out large sections, major geomagnetic storms have knocked out large sections of the country into power blackouts and so forth. So this is something that you keep track of. And you can actually get hundreds of amps in pipelines and so forth. Okay, so The other thing that happens is the radiation events. S1, S2, S3, S5. S1 is not much radiation event. By the time you get up to S3 and S4, you realize, hey, you get a lot of radiation on aircraft. And S5 is, oh my gosh, let's not fly. Let's an S5 storm that happened a number of years ago when there were astronauts in space, even though they're inside the Earth's magnetic field, they received their entire lifetime supply of radiation in one event. That was the end of their career as an astronaut. They were grounded from that point on. They could never fly again because they'd already exceeded the maximum safe occupational radiation for their career. If you get a storm of that caliber outside of the protection of Earth's magnetic field, it is lethal. So that means that if you had astronauts on a mission to the moon or to Mars or something and you had a storm of that category, they would receive a lethal dose of radiation in that one event. In fact, even lesser storms would give them a lethal dose. And then radio blackouts, rated R1 to R5 also. R1 is very little effects. You might notice some static or so forth up to R5, and that is you have blackouts on large portions of the radio frequency band and large portions of the Earth. And so, once again, the different levels of blackout here depend on how bad the storm is. And so these rating scales are actually available from the Space Weather Prediction Center, and so you can look at them and see how these things work. And so that again is a measure of space weather. And again, the Space Weather Prediction Center, they issue geomagnetic storm watches and geomagnetic storm warnings. You can actually sign up for emails that you get the watch and warning bulletins, and you can actually get a warning. And then just like they do forecasts for hurricanes and tornadoes, particularly for hurricanes, they say we think it's going to be this strength and going here. They say the same thing. We think that this storm is going to be this strength and it's going to hit this side of the Earth for about this long period of time. And so that's the sort of thing that you can sort of notice.